Hello, this is Sumit Singh, final year student, EC department from Veltech University. Our title is An Efficient Pipeline Cryptography Architecture in FPGA using vhdl. We are the members of three, Sumit Singh, Praful Kumar Joshi and Indrajit Gupta. Our external guide is K. Rani Madam, internal guide is Gaddam Vinay sir. We are working in an SCL Career Development Center. Our abstract is the core implementation of AES by applying pipeline cryptography architecture in FPGA using vhdl. The existing AES system is slow and consuming much more time. By implementing pipelining technique in AES, faster result can be achieved. The implementation is very efficient, achieving 318 MHz on a Xilinx Spartan 3, representing at 50% faster than other. The implementation can achieve 800 MHz on a Xilinx Vertex 5. What is cryptography? Study of technique related to all aspects of data security. Here is a concept of advanced encryption standard. This is a block diagram which you are seeing over here. In the advanced encryption standard techniques, in which we are using Array-Zindal algorithm, here we are using 4 processes: substitute by, shift rows, mix columns and add round key. Transformation. To provide security, AES uses 4 types of transformation: substitution, permutation, mixing and key adding. Here is a block diagram of substitute bytes. Here, every blocks of a data is being substituted by the S box, and in this way full blocks is being substituted, and then it proceeds to the next process. The second process is shift rows. Here the data block is being shifted by 1 and shift rows process is being processed in this way. The third process is mix columns. In mix columns, every column of data block is being multiplied with a constant predefined value, and we are getting a new value. Then it is proceed to the next process. And here is the add round key. In add round key we are using XOR operation, by which we are getting a new value. In this way 4 processes is being done and proceeds to the further. Here we are using pipelining technique. In this technique, the technique by which all the 4 processes being operated simultaneously without waiting for the current process to be completed. Let's see something about the existing system. What is an existing system? The non-pipelined architecture of AES is used in existing method. The main disadvantages of this system is it consumes much more time and the process is very slow. To overcome it, pipelined architecture is being implemented. What we are doing in a proposed system, to develop a pipelined cryptography architecture to achieve 50% faster result than the previous non-pipelined architecture. The implementation is very efficient, achieving 300 MHz on a Xilinx Spartan 3, representing at 50% faster than other. The implementation can achieve 800 MHz on a Xilinx Vertex 5. Here is a block diagram of a pipelining block diagram. One block is being processed simultaneously with the delay of some time. The another block, that is the another process, is being processed. In this way we are processing all the 4 processes which we have already showed previously in a Array-Zindal algorithm. Let's see something about the pipelining concept. What is the concept of a pipelining on which we are working? A process operating on an input task and producing an output result. A stage composed of 1 or more identical works concurrently processing a stream of tasks. Third point, a pipeline of stages linked together, output of the upstream stage fed as input into 1 or more downstream stages. Estimation of pipelining. As we are increasing the levels of cryptography, we are looking that time interval between input and output ns is reducing with every level of cryptography. If the levels of cryptography will be 1, the input output time interval will be 13 to 5 ns. If the levels of cryptography will be 2, the input and output interval of the time ns will become 7 and 5, and if it will be 5, it becomes 6. In this way you are looking that in every levels of cryptography the time interval is being reduced. This is encryption. This is encryption output which we will be getting after the processing of this. After the pipelining technique is being implemented, we are getting the encryption technique by using vhdl programming language. This is for decryption, which we are getting over here. So let's see about encryption. Here is a 128 bits we'll be fetching over here. This is a cipher key which is being processed and fetched over here. And in this way we are giving clock reset, and it is being processed by 4 process, and we'll be getting the output. In decryption, the reverse process of the encryption is being done. The same thing, everything which is happening over here, ciphertext is here, cipher K is here, and we are getting the reverse process, and we'll be getting round 0 after the completion of the full process. This is the output. This is the desired output we'll be getting after the process of this full project. Thank you.